Okay, so let me open up the question first. So your exam 2 take home portion. All right, let me open the screen and we'll move this to here. All right, so this is your take-home exam, and now let me know, do you have any questions about SQL statements? So basically, each statement is 2 points, and if you make any mistakes, at least 0.5 points will be taken off. But then if you have a serious errors, let me see what is going on here. Why does it ask me to log in again? Okay, so typically, if you make any mistake in that, as a 0.5 point will be taken off. But if you have a serious mistake, then maybe you have no credit be awarded. So the first question is find the location of sales department. So what is given is sales. Okay, the name of department is called sales. So you say select log from dpd where the name equals to single quote sales inside. So this is a very basic one, right? So you are given the tables, so make sure that all the names of columns, name of tables must be consistent with this tables with what is given. And then what is the information given is that the sales department, okay? So you cannot use anything else. And then the second one, find all the salesmen hired before that and use the format specified. So this one actually says that you have to use specified format. So that means if you do not use the format, then you will get a partial credit for that. Okay. So what is the answer for that is, let me just try and do it here. So you want to select salesman. So you're going to say name, right? Because there's no column called a salesman from EMP, and then say where job equals to salesman. And then hire date. So make sure that the hire date is less than. Okay, so if they greater than, you will have like some points, 0.5 point at least taken off. And then you say to date. Oh, this keyboard is bad. So to date. Okay, and then make sure the string is 01 and 1982. And that should be interpreted as months, DD, and YYYY. So that is what it's asking. Okay. So of course, if you miss like to date, you do not use the format, or you do not use the correct format, then put one point will be taken off. So basically, this job here, job equals the salesman, is also another thing I will look at it. Okay. So if you miss that, you will be taken off at least 0.5 point. Okay. And I find all the managers whose name starts with M and ends with R. So in this case, you basically will have to use I'm trying to do here. So you can say select name, okay, from EMP, and then say where job is equal to manager. You have to say that, and name like. And say start with M, so first letter is N, and then the percentage sign ends with R, capital R, capital R. So that is what I'm looking. And then this question you give 5% salary increase. So of course this is update, right? So if you do any other type of statements, then you probably will lose all the points. Okay, so here. I'm going to say update EMP, set salary equals to salary multiplied by 1.05. Okay, and then you have to do that for only salesman, right? For clock, sorry, job equals to clock. Okay. Next question, delete all salesmen who make less than $200 in commission, including who have not earned any income. So that means those commissions we have, including those who have no commissions. So say delete from EMP, and then say, well, so first of all, you're going to do that for job for salesman only. So salesman, and so then here, so salary must be less than 200. No, I mean commission. Okay, commission must be less than 200, but also including those who have no commissions. In those cases, should be interpreted as zero commission, right? So actually, you have to put inside the parentheses. So com is null, or com is less than 200. So you have to put inside the parentheses. If you don't do that, the logic will be incorrect. So this is less than, sorry. And next, find all employees. Let me know if you have questions, okay? Otherwise I will move on. Find all employees in dollars who make more than $300 in salary. So you still find individual records employees. So select name. Maybe we can put a salary here. From. Now here we are looking at two tables. We have to join two tables. So we can do EMP, inner join, and DEPD DEPD number equals to EMP.DEPD number. Okay, so after we have that join the table, then we can use all the columns. So location is equal to dollars. Yes. Okay. And salary is more than 3,000. Okay. Next, find the total salary. So when you say total salary, then you are doing groups. You are doing statistics. Okay. Of those employees who have letter J inside their name. So here we are not doing any like a factor analysis. We're not say group all the employees. So we basically just select employees only, right? So we'll do select. The total salary should be sum of cell from EMP, and then say, well, ename like, so have J inside, so that there's letter J inside. So it can be anything before, and then have J, and then after can be anything like that. So that is basically is like us, doing simple statistics without dividing the cases. We only select cases. Next one, find the year in which employee hired to make minimum salary. So again, minimum salary, that's a statistics, right? So we have to use group by or having those type of things. So, but we are looking for year. So select to char, and then say hire date, and then we'll do year, get a year number only. So Y. Okay, from EMP. Okay, we do not have anything like selecting cases, so we can directly go to group by to chart again, the hire date, and then Y up. Okay, and then we use their minimum salary to select the year. So we have to use heaven. Okay, and then minimum mean of cell is less than 1,000. That's 10,000. Okay, 1,000. All right. Next, you create a list that shows the department name, the number of employees, maximum salary, minimum salary, total salary, and the standard deviation for each department. Okay, so we are doing sort of like a group by, right? Group by department name. Okay, so select the name, and then we list all the statistics we want. So count, number of employees, and then we do maximum salary, max salary, or sum salary, total salary also. So okay, and then max, mean, then standard deviation, STDEV. Okay, and then we do, so remember we have to get a name and also salary, so we have to use join. So join. So in this case, we could do just left join, just right join. So basically we do EMP and then right join DEPD, because we are using department name as a focus. Okay, so if department does not have employees, we'll count as missing values, but every department name will be listed, in other words. DEPD, the DEPD number equals to EMP, the DEPD number. Okay, and now we can do group by DName. Okay, so when you select in group statistics along with the column names, and that column must be the ones after group by. Okay, that is I emphasized a couple of times. So basically, in this case, you are creating groups, and then the DName department name is like a group label. Okay, and then you show the group label and also some statistics inside each group. Okay, so that is number 9. Number 10, find those jobs whose maximum salary among the people hired after 1981 is more than $2,500. So we have a couple of things here. So first, we reference the maximum salary, and then what is the maximum salary? Must be 2,500. So that is that condition. That condition is used for selecting groups, right? So because it's reference to group statistics. Another condition is people hired after 1981. So that is actually help you to select cases, right? Because that's not a related group. Instead, it's related to each individual employees. Okay? So in this case, we will do select cases and also divide cases. So looking for job from EMP, and then say where hire date is after 1981. So we can just do to date. Okay, and then 1981, and that is interpreted as your number. Okay, and do group by job, and then finally having maximum salary is more than 2,500. Okay, so that is the answer to your SQL statements. Let me pause for a second to see whether anybody has questions on this, on any of these SQL statements. Yes or no? Okay, if there's no question, let's move on to question 2. So this question asks, say, this is a company XYZ uses this table to manage invoices and payments using the following database table. Does it conform to the second normal form? Why or why not? If it's not in second normal form, normalize it. So basically, you need to do both. Okay. So first, you need to make a second normal form justification. Judgment. First of all, make sure that is not in first normal form violation, right? So I guess no column has no cell has multi values, right? So all cell has single values. So this table is already in first normal form. And does the table have a primary key? So now for that, you have to look at that here. Payment ID is not a primary key. Invoice ID is not a primary key either. How can you tell? Because they are repeating, right? So 9088, and this is HT243, 234, 234. So you have repeating values. So those columns, these two columns alone cannot be primary key. So now you have to probably think about, maybe they have both combined together. Okay. So what happened here is you can just imagine that in the real scenario, in practice, you have invoices, right? And every invoice you can pay multiple payments, I guess. And sometimes one payment can be used to make multiple payments, right? So the relationship between payment and invoices is many to many, okay? But then whenever you combine things that with many to many relationships, then you are violating second normal form. Does that make sense? So therefore, in this case, it's very likely it's violating second normal form, okay? If you say no violation, then that's totally wrong, okay? You lose all 5 points. I don't think anybody did that. And then based on this many-to-many relationship, if you combine them, then you basically get a primary key. In this case, will be consisting of both payment ID and invoice ID, okay? So the primary, so PK equals to, then payment ID and invoice ID, invoice number. So that's the primary key. So that's the first thing you want to do. And only after that, you can say that the table is not in fourth normal form violation, because fourth normal form requires that no repeating values and also there is a key. Okay, so of course this one has the key. And the next thing you want to do is you want to show functional dependency, right? So I'm going to do that using the whiteboard here. Let's move this up. And so the functional dependency, if you're trying to draw that, that would be, let me see, you're going to have something like that. Let me see whether I can draw directly on Microsoft Word file. I hope I can. So here you have a payment ID, which determines, yes, I can, determines the payment amount, right? And the invoice ID determines invoice date, due date, and also amount due, right? So they're basically just pretty much common sense, right? So we receive invoice, we tell you what is due date and how much is amount, right? And you can also look at the data if you want to see the amount will be depends on the invoice only, okay? And what about the late or not? Well, for that you have to be careful. Does that, for example, so we have a 9088 here, 9088, okay? So that is yes, and then there's another 9800. The answer is no. The late is no. So that means that the invoice ID, invoice number does not depend on the late or not does not depend on invoice ID, invoice number. Okay. So if you have functional dependency, that means if I give you 9088, then there's only unique answer, whether it's late or not. But in this case, it's not unique. So therefore, late or not does not just belong to that. So as a matter of fact, it will belong to both. So that also is common sense. So basically, when you have, say, one invoice and make multiple payments, but maybe some payments are late, some payments are not, right? Because if you're combining multiple invoices to make payments, the invoices maybe some payments may be late, some payments may not be late. Okay, not always. Everyone is late, everyone's not late. Okay, so we have a functional dependency like that, and then after that, we should make a judgment that the table is not in second normal form because of partial functional dependency. So you can point out which are the ones. So first one is the payment ID, determines payment amount. Okay, and you also have other ones, so that and invoice number determines due date plus amount due. Okay, so those are partial functional dependencies because primary key, the determinant, payment ID, and the invoice ID are only part of a primary key. The primary key is this one, right? Is a primary key. Okay, so how do we fix? So that is a pretty easy procedure. So basically, you're going to list every part of a primary key. So payment ID that determines payment amount. So to use that to make a new table. So payment ID as a primary key, and then payment amount as non-key column. Payment amount is non-key column here. So this is first table you get. And then from the second one, so let me make more spaces here. Does somebody have a question for me? And the second one is invoice number. Determines due date and amount due. For that, you make a new table with invoice ID as a primary key and the due date, and then amount due as non-key column. Okay. And then finally, so this is the second line, and then third line should have, trying to create the modules here. The third line have payment ID, and invoice number. That determines late or not. Right? For that, you need to make a new table also. So the new table will consist of 3 columns. Include payment ID as part of primary key, invoice number as well as part of primary key, and late or not as non-key column. So essentially you have 3 tables, one table about the payments, one table about the invoices, and then you have like a gerund in the middle, the junction table or gerund, right? So that is, so if you draw ER diagrams, so basically you have payment entity, invoice entity, and also gerund, which has only one attribute, which is late or not. Okay, and then the second procedure, second normal form, the procedure to fix second normal form violation is clean, so you do not need to check again. So this is guaranteed to be in second normal form already, because the question was asking for second normal form only, right? So you do not need to check third normal form. Any questions? Okay, and then the last question. The following is a table for all bank branches to record their transactions. Okay, each branch records its transaction using the branch's own local transaction serial number. So that means this transaction serial number is only valid within the bank, within the branch. Okay, so that means one branch may have serial number 1, 2, 3. Second branch also have serial number 1, 2, 3. So in that case, transaction number cannot determine transaction amount. Does it make sense? Because those numbers may be repeating by different branches. Okay, and then let's continue. Amount and type, along with the employee who conducted the transaction, and then it says each employee works for only one branch. Okay, so if you know employee, then you know which branch it belongs to. So therefore, you have functional dependency from employee ID determines branch. Okay, and now you ask, will the employee ID primary key, some kind of key or candidate key for this table? I guess not, because each employee can make many transactions, right? Each employee can conduct many transactions. So therefore, employee ID is not a key. So this table is not in voice card normal form because the determinant in this relationship, employee ID determines branch. Okay, is not a key. Let me see whether I have more space. Yeah, is not a key. So that is enough to make judgment. And then with that, the functional dependency, now we can start with fixing. So,
Professor?
Yeah.
I said that transaction amount and transaction type were dependent on the transaction serial number. Are those all like not related? There's no functional dependency?
No, that's incorrect. That is incorrect because as I said, because each branch can use transaction number independently. So for example, Akron branch, you can say transaction number 1, 2, 3, right? And then Copley branch can also have like a transaction number 1, 2, 3. Okay, so in that case, if you just say transaction number equals 1, can you tell what amount is it? You cannot, right? Because Akron transaction and Copley transaction may have totally different amount.
Okay, I see.
Yeah, okay. All right, so now with this, we are ready to fix. Okay, so we start with employee, what is called employee ID, determines a branch, that make a new table, employee ID as primary key, and the branch as non-key column. So then everything else plus the transistor, which is employee ID, will make a new table. So what is everything else? So if you look at the original table, everything else will be included, not include the except the first two columns. You have transaction number, transaction amount, and the transaction date, a transaction amount date type. So basically everything else will be transaction serial number and the transaction amount. Transaction is the amount or date? Transaction amount, and then type. Transaction amount and the transaction type. That's everything else. But then you have to add employee ID back. So I will add here employee ID. So that should be foreign key here, right? And that'll make a new table. Okay. And then the first table, the procedure for fixing is not clean, so you may need to do it again. All right. So if you let's look at the first table, this one is there's only one functional dependency, and that function, the determinant is already key, so this is already a Boyce Codd normal form. Okay. Now what about the second table? Can you think of any functional dependency? So I guess transaction number cannot determine transaction amount and the transaction type. However, if you know both of them should jointly determine transaction amount and also transaction type, because that transaction will be unique. If you know the employee and also transaction number, then that transaction will be unique, right? Because the employee works for only one branch, and then that branch will use, serial number 1, 2, 3. So if you know employee, then you know the branch. Then, if you know the transaction number, then you will be able to uniquely identify the transaction. That includes transaction amount and transaction type. So in this case, this is already primary key. So this is already Boyce Codd normal form. Okay, so you end up with these two tables. Now let me tell you how I grade these kind of questions. First of all, you have to say reasons. Okay, say answer why, and that will be 2 points. Okay, so if you miss something like that, like say why this table is not a second normal form, you forget to show the functional dependency, for example, and then the 2 points will be taken off. And then you have to follow the procedure to fix. So say if this is not a second normal form, then you have to fix it according to the right procedure. Okay, that will be 3 points. Okay, and then if you use wrong procedure, then you probably will lose up to 3 points, because because in property you also procedure. The same thing with Boy's card normal form. So first you say why not, and that will give you probably 2 points. Okay, so if you say it correctly, and then based on that you have to fix it. If you not fix it correctly, then you lose 3 points. Okay. Let me say what else. So if you in case you make a wrong judgment, say for example you say this transaction number determines transaction amount and the transaction type, then if you follow the procedure through, so you make a subtable. That table consists of transaction number, transaction amount, and transaction type. Okay, and then everything else plus the transaction number make a new table. So in that case, you have an employee ID and a branch and the transaction number make a new table. Okay, and then you have to look at that again to see whether the table is still in Boy's card normal form. I guess probably, if you don't see any functional dependency between employee ID with branch, then you say you probably can stop there. Okay, so if you follow the procedure, you may still make some points, partial credits. Okay, but if you identify the functional dependency correctly, but if you do not follow the through correctly, you lose credits on that too. Okay, so basically 10 points on normal forms. I'm pretty happy about quite a few students got this concept correct, got these 2 questions correct, and that is not a very easy questions, because normal forms and also building ER diagrams, those type of questions are not easy. Okay, writing SQL statements. So far, we pretty much we have done pretty basic ones, simple ones. Okay, so I do not see much difficulty. But for normal forms, I think we have covered pretty to quite a depth. Okay, so like a Boy's card normal form. So if you understand that, how to use that, then basically it shows that you master the concept of normal forms, normalizations. All right, and let me see whether you have any questions about this hands-on questions.
Is this exam not going to be curved?
Oh, this exam, good question. The average is 77 or 78, I believe. Let me double check. So usually if it is below 70, below C+, I will curve to C+. But let me double check on what is the average this time. I thought it was already over that. So you cannot see my screen, right? So I'm not going to show you grades anyway.
No, we can't see it.
Okay, so I will take a look. Progress report. No, not progress report. Just look at the grade. Okay, exam 2. Okay, so let me see. What? So average is 77. Okay, so 77 is C+, right? Is it? I believe 73 C, 77 is 78 or 77. I'm not sure. So if I do Coven, I can maybe just do like 1 or 2 points, maybe add to like a 79. Add to 79. That will be guaranteed that you get a C+. Okay.
And for our grades in the performance report, is our actual grade where it says grade, or is that the up-to-date performance?
You should actually use up-to-date performance.
Okay.
Up-to-date performance is one more accurate reflecting your standing. So let me see in this class, without a Coven, in this exam, we have how many A's? 1, 2. I see at least 3 A's, right? C's. And the most people get the B's, okay? And then we do have 1 or 2 people not getting satisfactory grade, just 1 or 2. So average this exam, you performed very, very well. I'm very proud of you. So I'm happy with this result. So without much covering, still get a good grades. Okay, I probably will just add 2 points to average to everyone, so that way we get everyone to like a C plus range. Average, I mean, the average is C plus. Of course, we have to consider that few students who did not perform well. So those students usually should be excluded from the calculation. So the result will be very different. Okay, now let me see whether you have any questions about the exam 2. If not, I will move on to somewhat advanced SQL. So we have at least 2 weeks to do SQL. Today is November 2nd, and then there's 1 more SQL. Those 2 will be very advanced. Today, especially today's topic, not today, probably not that difficult, but then the next week we'll see that some SQL statements can be very challenging. Okay, why they are challenging? Because it's just like you're climbing up. Now you're at a much higher level, so now you continue to climb, to climb higher. So you have to based on the foundation that you already have. Okay, so
I have a question. For the final exam, is that going to be a cumulative, or is it going to be just based on from here on out?
Oh, the final exam is going to be comprehensive. I think let me double check on syllabus. I think that's already stated in syllabus. So let's see. Yeah, it is comprehensive usually. Let's see. So it does not see in the syllabus specifically. Okay, no. So exam it only says that week 15 you have final exam. That's finals week. Okay, so it's not going to be it's going to be comprehensive. So that means you have to know pretty much everything from the beginning. That include how to build ER diagrams and how to convert ER diagrams into relational model, and how to write SQL statements to implement this relational model, and then how to do normal forms and how to write SQL statements. Yeah, and then after next week we'll switch to non-SQL database, so that we include non-SQL database too. So that's basically the nature. It's basically just cover everything. But I believe the majority of the points will be allocated to the last period. Majority of points. Okay, so I don't know how many points. Maybe at least 60% will be on the last period. Make sense? Okay, so you can tell that this technical classes is STEM classes always like that. It's always just step by step build foundation, then you move on, use the foundation to climb up to higher level. We cannot say that from now on we don't need to use concept of primary keys or foreign keys. Okay, we cannot use mapping cardinalities, the one to many, many to many, those kind of things. Okay, so especially when you get into SQL, we cannot use that. We cannot say that we will not use the basic SQL. Okay, so especially second period, you say that is going to be very, very important for the last period. All right, and any other questions? Okay. If there's no other questions, I'm going to close this session. So do I need to save? Maybe we can save that. Okay. So I don't need a whiteboard, but let's log on to Oracle SQL Developer. This is not it. Wrong one. I always confused with 2 symbols. They look very similar. They're looking pretty much identical. So this one should not be there. This is data model. I should close it. Okay, so log on to SQL. Invalid username. What's happening? We try it again. Wow, login denied. Oh, I know what's going on. I turn on the cap lock. Okay. All right, you say that it's SQL. So has everybody logged in? Now, after you log in, let's just do a couple of warming up. Do I need to warming up questions? It's already reviewed exam. I think we can just go ahead to do the main thing, right? Can we? So let me say, let's look at week. I think the label is week 11 now, because week 10 we had an exam, so now it's week 11. Just make sure you make a correspondence between this weekly outline and also your homework number. You should subtract 2, I believe, because we have 2 exams, right? So 11 minus 2. So next homework should be homework 9. Okay. So let me take a look at that. So what we're going to do is we are going to do something called subqueries. Okay. So before I do that, let me just state that there are a couple of rules that we need to follow. There's a rule of SQL. So I can say SQL programming or maybe SQL games, okay? Programming. Okay, so what are the rules here? The first rule number 1, is that for each query question, you have to write just one statement. One statement for one query. Okay, so that makes sense, right? So if it's a problem, it's just one problem, you cannot use multiple queries. Does it make sense? Okay. Second, I think we talked about that in the previous class. Let me just repeat that. Second one is statements. Each statement is based on what is given. Okay? So, in other words, you cannot make your own assumptions about what is given. Okay? So just like a previous exam example, I said that the higher date is 01/01/1981. So you cannot change it to a different format. Okay, and if I say I want to give Smith. If I say I want to give Smith $300 salary, $300 salary increase. Okay, you cannot assume that you know Smith's employee ID or Smith's job or whatever. Does it make sense? So make sure that you only write a query based on what is given. You cannot reinterpret that using different values, assume that's given. Okay, so let me try to start with so-called subquery. So let me start with a question. I think probably would be easier to just use question to start with what is subquery. Okay, so first let's just say I'm going to copy example 1 from the week 11 outline. Okay. Oh, what's going on here? Command. We did copy C here. Copy C, and then here I'm going to paste here. Cannot show history is what is going on with this keyboard. So that So I'm looking at this question, trying to minimize that. Okay, so let's do copy and go to here. Let's see, can I do paste? Yeah, okay. All right, so let's look at this example. The question says, you find employees who makes more than Blake. More than Blake. So now the question, so first part is easy. So if I know how much Blake makes, okay? So the question will be like what? So select, okay, employee, so ename, from EMP, and then say, well, salary. If I know how much does Blake make, then this query is very simple, right? So that would be basic statement. And then you may ask, can I just search for Blake salary and then use that one to plug into this question mark? And that is not allowed because you cannot create multiple statements for one query, first of all. Secondly, you cannot, you have the based on what is given, okay? You may ask, why do we have to follow this stupid rule? Well, you can say there's a stupid rule, but actually that is a rule guarantee that your SQL statement is correct and also efficient. Okay, so if you can split one statement, one query into two statements, then there's no guarantee that you may need to split one query into 10 statements or 100 statements. Okay, a statement can be done in just 0.0 second or no second, and then you have to take, your job will have to take like multiple days to finish. So that is not acceptable, right? So that's why we have to follow these rules. All right. So the question, find employees who make more than Blake. Okay, so we need the Blake salary, right? So how can we find the Blake salary? And that I think is easy. So that basically we'll just do something like this, right? We're gonna say select cell from EMP where ename equals to or like Blake, LACK, okay? Semicolon. So this is basically this simple statement will help us to find out how much does Blake make. If I know that, then the main query that is to find employees who make more than that should be easy, okay? So what we could do instead of doing this separate query, this is what we do. We just simply copy that, cut this. This is the window. This is Windows. I got okay. I did something okay. So this is just trying to use Mac keyboard for Windows. All right. So for that question mark, this is what we do. Okay. We have an unknown, right? So we will replace that question mark with parentheses, and then write a statement as usual to find what is unknown. So that in this case will be just finding that. Cell from EMP where ename equals to Blake, and the subquery will not have a semicolon, so delete that, and the entire statement will just have one semicolon. So therefore, we have this result. Okay, so basically this is what we find: employee from EMP where salary is bigger than Blake's salary. So Blake's salary is unknown. We use subquery to find it. So this is so-called subquery, and this is called a main query. Okay, the whole thing is main query. See that? So main query includes subqueries like that. So that applies to any unknowns. So in case of unknowns, you use subquery to replace it. Okay. So let's run that, and hopefully there's no error. Nobody bigger than Blake. Let me just use less than. Let me see whether that make any difference. Make less than Blake. Okay, so let's see. It's still incorrect. So, or black. Is it black or Blake? I think this is wrong. The name is incorrect, right? Is Blake? Is it black or Blake? Let me check that. I think that should be the name. Yeah, that's the reason. So this should be Blake, not a black. Blake. Okay. So find employees who make less than, so in this case, less than, so I'll change it to more than, okay. More than Blake. So that would be the employees, Jean John's, Ford, and Scott. Those make more than blank. Does it make sense? Okay, so this is what is, so make sure when you do this kind of queries, okay, subqueries, find out what is unknown, right? So this is very clear, right? Break salary, and then use that break salary, then use the question mark to stand for the unknowns. To finish the main query. The main query is find employees who make more than. So basically, you're saying their salary is more than, right? So salary greater than question mark, and then you replace the question mark with the subquery, like that. Okay. So in the next few questions, I'm going to ask you something to do, something similar that you will have to do it, and then for each question I will give you 2 minutes, and then at the end of 2 minutes, you ask me whether you want me to give you an answer or not. Okay, if not, I'm going to move on. Is that clear? Okay, so let me give you the next question. The next question is find all employees who make less than Smith. All employees who make less than Smith. Okay, do that quickly and let me know whether you need help. I'll give you 2 minutes to do that. Put your hands on. You have to do all this exercise. This is how you learn programming, learn coding. By just simply watching, you're not learning. You get it? Does anybody get it? Or does anybody have questions, problems? So let me know if you need my answer. Otherwise, I'm going to move on to the next question. So this time I want to find employees who has the same job as Smith. Who have same job as Smith. Okay. So again, I give you 2 minutes to finish that. So this time, you know what is unknown. Smith's job, right?
Hey, Professor.
Yeah.
Could you actually show us the answer for number 2? Oh wait, never mind. I'm fine with that. I lied. I'm good.
Okay. So let me give you an answer anyway. So that would be select ename from ENP where cell is less than Smith salary. Select cell from ENP where ename is equal to Smith. Okay. So here we are looking for employees who have same job as Smith. So we're still doing same things. Ename from ENP. Well, so we are looking for job. Job equals to Smith's job, the question mark. Okay. So now I have to replace the question mark with parentheses and then semicolon end. Inside the parentheses, we need to use another query to find out what is Smith's job. So that would be select job equal from ENP ename equals to Smith. like that. Okay. Okay, continue the same line. Let's do one more question and then we get off. Yeah.
Can you actually run the makes
you
less
can
than Smith?
make it less than Smith? Oh, this one?
Yeah, previous.
Something wrong? So
You didn't have a parenthesis at the end.
Oh, I'm using parentheses. Okay, thank you. So sometimes you have to look at the previous statement. Previous statement may be incorrect, may not be. So let me do it again. So there's nobody less than Smith.
I was just making sure because that's what I got too.
Yeah, seems to be nobody is making less than Smith. Huh, that's interesting. Okay, so then look at the job who have same job as Smith. So we have a bunch of people like that. Okay, next question. Find employees hired after Smith, I think. After Smith. Okay. I'll give you 2 minutes to finish that. Okay. Do you get it? So here you're looking for employees also, so ename, maybe their hire date also, right? Okay. From EMP. Well, so basically you need to make sure that the person you're looking for whose hire date is after Smith's hire date. So after Smith, so greater than. So let's find Smith's hire date. Select hire date from EMP, where ename is equal to Smith. Right? So that is basically same idea. Okay, same idea. So it's looking for something that has unknowns. And then in all these questions, we have only one unknown, and then you write this subquery to find out one unknown to substitute the question mark. Okay? And I think it's almost time. Let me ask you whether you have any questions before we finish.
I have a question.
Yeah, you have a question, yeah?
So for this last example that we did, what if it was hired after Smith, but before another person? Like if they were two people's names and then wanted before and after? Would we just put and then do the hire date again?
Yeah, that's right. Basically, just say and hire date, say less than for something. Okay, then find out another person's hire date. You can do that. Yeah.
Thank you.
Yeah, good question. Any other questions? Okay. If no more questions, let me stop the recording. And then